Google Maps know what we're living on, though, don't they?
They will know damn well.
Absolutely.
I mean, we're storing some readings, compass readings on Google Maps, and when you can get the whole of England in the picture, everything is straight. But the moment you start to pan out, everything bends, or everything curves. The land curves. But even you can have the whole of England in there, which is still quite a big piece of land, and the lines are straight. And then they also loop it. So Google Maps know exactly what we're living in.
Something this obviously isn't the real map, right? But it's a visual aid, because I was trying to figure out,
Hang on.
in my mind, how Sirius explains it as the looping thing, right? Because I'm still trying to figure out how you fly and make a flight from LA to China, and to make things connect, in a physical.
Well, I'm always saying, take the
physical
point always in the middle.
Right. So what I did is I took a square, right, a basic cube, four-sided square, and then I just curve the corners in, right, enough just to make it so it appears like the globe model that Google is using, right, and then I superimposed a GPS accurate map that's actually the flight maps, right, because we were talking about the flight maps the other day, right, and then what I figured is, you can see if I zoom in on it a little bit here, and I'll rotate it slow. So I mean, it's an accurate to scale, right, map of the flight path, right? So I was trying to figure out, well, how do you get from, say, wherever, and why aren't there any flights across Antarctica and so forth? And they keep saying, oh, well, it's a slightly oblate spheroid. So that's kind of how I morphed the squared and then laid the map on it, right?
Yeah.
Right. And then the fourth dimensional thing came into it. Is like when I started, scaling things up and down, right? So when I looked at the North Pole, when you go on Google Maps, Google Earth, and you zoom into the center of the North Pole and or the South Pole, right? You always see this circle above it that is warped. It's always warped, right? So if I flip my ball I made, right, to simulate theirs, and you go into Antarctica, you'll see that whatever, all that data from the flat map you have is being morphed, like you said, morphed into that single point, right?
Yeah.
Right. So I want to say, how did they do that, and why are they doing that? Why is it always that way, right? Just to answer the question. And then what happens is, I'll just take this, give you a little bit bigger screen here if I can. If you start changing the thickness, it's an inverted double-sided square. So if you start changing the thickness, watch what happens.
Yeah.
The North Pole starts coming out of the top. So here's Antarctica inverted, right?
Yeah.
And then it starts coming out again, right? It'll start flying. It'll come out until you end up with a pizza map, right? If I zoom out, right? So you can infinity keep rolling it in and out, in and out, in and out of itself, right? You'll end up with an azimuthal equidistant map, right? Eventually, if you scale it right, and it just keeps rolling and rolling and rolling, right? So that's what they've done. That's how they've pulled it off. So that's why then in their pictures you end up with a square thing. So I thought that was interesting. That at least now I know what they're doing, right? Right? You can morph it inside and out of itself forever, right? And still end up with a globe, right? And the flight paths are accurate, etc. Because it's a real map, right? So, so we're on the trail, right? Yeah, it's interesting. Yeah,
It's really annoying though, isn't it, as well? Because you're taking data that comes from them.
Yeah,
it's
exactly.
the only data.
Right. Yeah, that's the problem, right? The only data we have comes from their model, right?
Actually, put it in a ball, you actually twist up all the distances.
That's correct. Yeah.
I mean,
everything is warped, right?
The lines, etc.
Yeah. Yeah, that's why when you go on to Google Maps or Google Earth, you can't draw a line 90 degrees on any line of latitude and maintain a 90-degree heading. Like if you started in Alaska or whatever, and you said I want to go 90 degrees east or west, if you hold that heading, you'll end up at the equator, right? Because they've warped it, right? It is a cube square, right, in the model and on the map, right, in three-dimensional or fourth dimensional would be three-dimensional sense, right? All the coordinates on the X, Y, Z are to a cube, and then they roll it into a ball, essentially. That's what they're doing.
Not to interrupt, but any word on Dave yet?
No, I just put a message in chat to say I hope he's coming back. No, he's not. No, maybe he's turned his computer on and off. I don't know. Sorry. Carry on, Chris.
Yeah, that's cool. And what got me onto that was I was trying to correct. This is kind of just interest. This is I'm not trying to go for the whole Masonic thing or whatever, but I was trying to remove the curvature from the flight paths, right? So if you fly from New York to Heathrow, England, right, London, England, on the maps, there's always that arching curve, right? And no plane would fly, they would leave, 45 latitude, fly up into 60 latitude and drop back down into 45 latitude. It makes no particular sense, right? If you're pretty much running a straight line. To a degree you would, but not to the extent that they're showing. So the only way to straighten that out so that it makes sense for straight line from South America to there, straight line in any direction, it's a pyramid, right? Pyramid and roll it into a ball, right? And that's what you end up with. Very strange. Yeah.
Keeps all twisted here. Yeah, it's a way to find out how to actually. That's why I like to actually completely start from the start.
Yeah, go backwards. Yeah.
Circle and the squares, making them actually cubes.
Yeah, that's what we're doing. Yeah.
Cube set. And the only way you can actually explain the next level is by closing these circles. First of all, fourth dimension as an 8-figure, folding the dimension in two sides upwards and downwards, that it meets in the middle, and then you have the fifth dimensional actually also the up and the down as the below fourth and the up fourth. And that you can actually put in a part of the snake of the 7 chakras. And that's the bigger step beyond there again.
Yeah, you get into
level,
that.
Yeah. Build it up and eventually twist reality into those dimensions to see those dimensions in the 3D on 2D. It's a bit, you're still explaining the next levels, but yeah, it's kind of this.
Thanks for explaining, Chris, how they made the the round map then. Thanks for explaining to everybody how they did that.
Yeah, if you take the same, if you take a donut, like a torus donut shape, and then scale it down slightly on the z-axis to make it flatter, like a pizza dough, right? And then you do exactly the same thing with the globe map superimposed on that, and then you roll it inside out, right? It will do the same thing. I'll see if I can pull it up here just to show you exactly how that's working too. I compared the two. I'm trying to go after it all, right? Just a second here, because I think I got one set up for that as well. We can turn off the.
Yeah, that was my whole setup as well, actually, to disprove any map what doesn't.
Yeah.
But
any map don't work, disprove it.
With the map what does work.
Yeah.
Before I knew it.
Okay, let's go screen share application window again. Try this one. Now I go. This one.
Oh, as a donut.
Yeah, I was going to see if I could get that one to work too. I had this working the other there last night. But then I went and changed the shape of it a little bit. But
yeah, it's always the question: where is the measurable curvature?
yeah, when you go to that. You can really start to see how it's being manipulated, right?
Yeah. It seems like that Buddha map.
Yeah, so that's kind of, it works the same way, right? If you start rolling it out, right, you'll end up with the
double ice ring. Yeah.
Right. There's the ice ring. It'll start to form. You can see it. I don't have this quite perfect, but last night I had it set perfect. You just got to scale it a little bit differently, and right, scale it here. Go onto the z-axis. Scale it down a little bit till it's almost flat. Right.
Whoa.
Right. Scale it down, and then you can start manipulating the right rings inside of rings inside of rings. Right. It keeps making the same. Right. Right. So you can generate any map you want, right? I mean, there would be, the ice ring's melted, and here's a map, whatever, so many years from now, and we got a little bit of islands of ice, and right. So that's exactly what's happening in the 3D data, right? It's a UTM manipulation on the 3D.
Yeah, exactly.
And I like this one here when you zoom it like that, because this is the because I was trying in the square map, the flat map that you sent me there, right? And the all the data that's in the southern part, which is the Antarctica ice, right? Because when you start stretching that out, it's like, wow, there's all these mountain ranges and everything down there, right? It's been squashed into the center pole, right? So all this white area here is actual imagery from Google Earth, right? That's exactly what it looks like when you stretch it out into a donut and then zoom into the top, right? Right. Or flight path, right? Because I'm trying to figure out the flight path, right?
See, that's the whole thing with the circle map, is that they don't want you to know that there's more land up north.
Well, that's exactly it, yeah.
I will get a list of all the airplanes of fields in the world, and then lay in a grid of all the possible flights. I don't know.
Yeah.
It's really great to sort of at long last see how they managed to make the round map, though.
Yep, that's exactly how they're morphing it. Yeah, all that data is squashed into the poles, and it warps it completely out of it. It makes no sense, right? They've warped it.
I hope everybody in the chat room can now see how they lied about that now.
Yeah, because I can zoom in like on.
Carry on.
You can tell that this is this. You can tell that this is the actual data right straight off of the. You can zoom in right down until you see these are the mountain ranges and everything that's in there, right? Yeah, so we're trying to see. I want to, once you understand what they're doing and how they're manipulating the reality, then we stand a whole lot better chance of coming up with a map, at least something that's But it's still hard, like Siri says, right? The only data that we really have to work with is from Google Earth and so forth, and they've already potentially manipulated it to fit the globe, right? So who knows it,
Or they can't fit the globe on the photograph,
right?
and that's the point here.
Yeah.
That's how they actually show the truth right in our face as well.
Yeah.
It's just finish the map for what it is. They just hide 2/3 of it.
Yeah.
And we think it's only 5 degrees from the 180, but it's 2/3 of the y-axis.
Yeah, and seeing
through
that
the form.
the map that they're warping into a globe it might just be a piece of a much larger, piece of pie or whatever, right? It could be, there could be stuff out there I've never had access to, right? Ever, in any sense of the world. It was too far away or whatever, but it's very difficult to see, who knows?